Have you ever taken a train in the middle of winter and wondered how it keeps moving through all that snow? Hidden behind every safe journey are machines you rarely see, massive engineered giants built to fight the cold. Today, we'll follow them into the heart of the winter railways. Our first stop takes us to Japan, where winter snow rises to levels that ordinary trains cannot handle. This is a rotary snowplow, mounted on the front of the DE-15 diesel locomotive, a machine built to punch through walls of packed snow. Two side plows pull the snow toward the center, feeding it into a heavy steel auger. The auger breaks dense, compacted layers and pushes them into the impeller chamber. There, a high-speed impeller ejects the snow upward and outward through a controlled discharge chute, clearing several meters of snow even at low speeds. It's a system designed for regions like Niigata, where a single storm can shut down an entire railway overnight. Our next machine takes a different approach, not blowing snow, but splitting it apart. This is the wedge snowplow unit mounted directly on the front of the DE-15 locomotive. Its reinforced V-shaped blade cuts into compacted snow and pushes it outward using pure weight and momentum. Unlike rotary systems, the wedge plow has no moving front mechanisms. It simply lifts the snow off the rails and forces it to both sides as the locomotive advances. Expandable side wings can fold out when needed, tripling the clearing width on long, open sections of track. This makes the setup ideal for conditions where the snow is deep but not ice solid. Simple, reliable, and mechanically tough, the DE-15 fitted with a wedge plow remains one of Japan's most dependable snow-clearing tools. Our journey takes us across the Pacific to a place where harsh winters shaped a very different design. This is the North American wedge plow, a giant steel battering ram in the shape of a V pushed forward by an entire locomotive. No augers, no rotors, just weight, speed, and a blade thick enough to split compacted snow. As the train charges ahead, the plow cuts straight into the snowbank, lifting tons of packed snow in a single impact and throwing it into two massive white streams. Its extendable wings widen the clearing path, creating a clean corridor in just one pass. A design built for open terrain, long distances, and winters that never go easy. On the remote rail lines of Canada, this remains the most effective solution. Hit the snow head on, hit it hard, and keep the railway moving no matter what. Leaving modern machines behind, we move to a far older design, one that's impressive in its own way. This is the steam-powered rotary snowplow, a machine over a century old with its massive front wheel driven directly by a boiler system. No diesel engines, no hydraulics, just steam pressure feeding a mechanical gear train to spin the cutting rotor. As the wheel gains momentum, it tears through compacted snow, throwing it upward through the chute above. Its heavy frame and slow, steady operation allow it to cut through deep drifts without relying on speed. And despite its age, this steam-driven giant still has the power to keep Switzerland's mountain railways open, places where winter remains unforgiving. Leaving the rail tracks behind, we arrive at a machine built for a completely different style of snow removal. Faster, stronger, and far more agile. This is Norway's off-road auger snow sweeper, a purpose-built vehicle capable of throwing snow up to 10 meters high. At the front sits a dual auger system, chewing through deep snow and feeding it straight into the grinding chamber. Behind it, a 650 horsepower engine drives a high-speed impeller that sprays the snow outward as a fine mist, preventing large drifts from forming. But the most impressive part is its speed. This machine can operate effectively at 60 kilometers per hour, clearing the road while moving, processing snow continuously in a single pass. With a total weight of more than 37 tons and reliability in harsh northern climates, it remains Norway's go-to solution for mountain routes buried in snow year-round. Across the vast rail network of Russia, snow control demands far more than brute force. This is the CM2, a precision-built snow cleaning system unlike any plow or rotary design. Instead of relying on speed, the CM2 crawls slowly along the tracks, using a rotating brush assembly to sweep the first layer of snow from the rails. From there, an auger pulls the snow inward, feeding it into the central processing chamber. A powerful conveyor lifts, brakes, and channels the snow through the machine's internal path. Only then is it expelled through side discharge ports, leaving the railway fully cleared and leveled with exceptional accuracy. This method produces a far cleaner result than wedge or rotary machines, though it requires much more time to complete. But for railways where precision matters, the CM2 remains one of the most specialized and finely engineered snow removal systems in the world. If the steam rotary in Switzerland tears through snow with sheer mechanical fury, this machine is its quieter, humbler counterpart, yet no less enduring. This is the single-track wedge snow retainer, a 1940s design so simple, it's almost shocking that it still works today. No rotors, no augers, no grinding chambers, just a V-shaped steel blade bolted to the front of the locomotive. As the train moves forward, the wedge lifts the shallow snow off the rails and parts it cleanly to both sides, like splitting a river of white powder. It performs best when snow stays under 60 centimeters, just enough to keep the tracks open without any complex moving parts. And that simplicity is exactly what keeps it alive. Low maintenance, high reliability, and always ready when winter returns to single-track roads. And then, there are moments when winter pushes everything to the limit. Niigata's historic snowfall of 2014 to 2015 was one of those moments. Faced with snow deep enough to shut down entire rail lines, a special machine was deployed, a high-performance screw and impeller snow cleaner. Twin side plows pull the snow toward the center, where a massive auger drags it into the main chamber. Inside, a high-speed impeller shreds the compacted snow and blasts it outward through an adjustable discharge chute. This system doesn't just clear the rails, it prevents towering snowbanks from forming on both sides, a major hazard for high-speed trains. Even when the tracks disappeared under meters of snow, the screw impeller design carved forward, reopening the line 1 meter at a time. And in the end, what makes these machines remarkable isn't just their power, but the way they keep people connected, even through the harshest winters on Earth.